All right, just wanted to do this problem for you in case you wanted more of an example of how to do it. So you want to prove this is an odd function by using this definition. Okay, so the way that works is we want to show f of negative x is equal to negative f of x for all x. Okay, so why don't we start with negative f of x? No, let's start with f of negative x. Okay, so what do we get? That becomes sine of the quantity negative x squared. Every occurrence of x gets replaced with negative x. All right, and now we simplify this. So sine of negative x squared. So negative x squared is x squared, so I get this. Now cosine of negative x, we've learned in class that cosine is an even function. So cosine of negative x gets to get replaced with cosine of x because it's even. And then the bottom becomes, so negative x quantity cubed is the same as negative x cubed. Okay? All right, so now let's go look. All we have to do now is go look at negative f of x and show that we get the same thing. So negative f of x would be the opposite, the complete opposite of this whole thing, right? Because this is f of x. So it's the opposite of sine of x squared plus cosine of x plus 1 divided by x cubed plus x. And then when you distribute a negative that's involved in a fraction, it gets to go either the top, out in front, or the bottom. We are obviously going to move it to the bottom so that I can write it as, I can write this expression as this. Right? So if I move it to the bottom, it's, and you'll notice, of course, now that that matches this. Okay? So, you know, if you want to be thorough, we say therefore, right? And that's the definition of odd.